Hello, welcome to In 5 Minutes. Now, there is one possibility that input can be a sine wave. In that case, how to solve the problem? If the input is a sine wave, so in this case, we need to see again in which half cycle the diode is getting forward bias. Now, when you look at the diagram, the negative half cycle makes the diode forward bias. Why? In the negative half cycle, we are providing negative terminal, positive to positive, and the diode is getting forward biased. So during the negative half cycle, the capacitor will build charge on it. Now the charging of the capacitor is as shown in the diagram. So when you apply KVL to the input side, what will be the equation for the KVL? This is, we are dealing with step 1. KVL to the input will give you VI or VI plus VC plus 10 equals to 0. Now VI is minus 20 plus VC plus 10 equals to 0. So charge on the capacitor developed is 10 volts. Now in the same half cycle, we need to find the output voltage. So for that, we need to apply KVL in the output loop. KVL in the output loop will be this side. How? Since the diode will be short circuited. So the diagram with the diode short circuited will be capacitor. Diode is short circuited. In the negative half cycle, you have the 10 volt battery and the output. This is where we are applying actually the KVL. So KVL will be from this side to this side, and this voltage is 10 volts. So when you apply KVL, the equation will be VO plus 10 equals to 0. See, the output voltage in this case will be minus 10 volts. This is how we have got the output in the negative half cycle. And for the information, we consider only the peak value in sine wave. So the peak value in the sine wave is minus 20. So for that peak value, we are getting output as minus 10 volts, right? Now this is what we have done for the negative half cycle. Now going to the positive half cycle, what will happen in the positive half cycle? Here we will have positive, negative, positive. The diode will be reverse biased, and the diagram for the diode will be, you have the capacitor whose direction is negative positive of the charge, positive half cycle. Then the diode will be open circuited, the battery will be redundant in this case, and you have the output voltage. Now in order to find the value of VO, input is going to maximum 20 volts, VI with respect to time. Now when you apply KVL from this point to this point, the equation of the KVL will be VI plus VC minus VO equals to 0. So VO will be VI plus VC. Input voltage we are going maximum till 20. So we are dealing only with the peak value. So 20 plus charge on the capacitor. Charge on the capacitor is how much? We have seen as 10 volts. So total output voltage is 30 volts. So what we can summarize is, in the negative half cycle, we are getting output as we have seen. How much we are getting negative half cycle? We are getting it as minus 10 volts in negative half cycle, and positive half cycle we are getting the output as 30 volts. So what we can say, peak to peak value is 30 minus of minus 10, which is 40 volts peak to peak, and our input is again peak to peak, we can say 20 to 20, that is 20 minus of minus 20 will give you 40 volts peak to peak. That means our analysis is right. Now how to draw the waveform? Now coming to the waveform, we can see for the minimum value of 20 volts, we are getting output as minus 10 volts, and for the maximum value we are going till 30 volts. Now in order to find the zero axis, the zero axis can be plotted down, and the value below the x-axis for the output is minus 10. So above the x-axis will get 30 volts. So total peak to peak value will be 40 volts in this case. In order to find the zero axis, or we can say the DC shift, so 30 minus 20 will give you the x-axis, and below the x-axis will have the 20 volts. So peak to peak will get it as 40 volts. This is how we need to do the analysis for the input when it is sine wave for the clamper circuit.